This podcast is brought to you by the School of Advanced Study, University of London.
Let's get started for what I thought was the first talk of the day, but it turned out not to be. This is Mahtani from the London School of Economics, and among her many talents, she's very good at drawing smiley faces, which you will find in your handout, which if you don't have, you should try to get one. Okay, thanks very much.
All right, well, thank you for inviting me. So my work at the moment is this strange sort of hybrid between philosophy of probability and logic and language. So there's all these problems and puzzles in probability, and I think some of them can be resolved by bringing in some ideas and news from the philosophy of logic and language. So I'm going to give you an example of this today. So the puzzles I'm talking about today are around this principle in probability called the reflection principle. And what I aim to show is that by recognising that there is intentional contexts at work here, we can resolve those puzzles. So I've only talked about this before with people who work on probability. And for them, the stuff on probability seemed really obvious, but when I mentioned intentional contexts, they were disgusted and outraged, I think. But I'm thinking maybe for all of you, the move that I made is going to seem pretty obvious, but I might need to spend some time setting up the probability stuff. So if I'm going too slowly over it, maybe you could interrupt me and tell me to speed up, or vice versa. Okay, so
Speed up.
Speed up. So the first thing I want to say is that the sort of probabilities that I'm talking about today are subjective probabilities. So say I've got a coin in my pocket and we're thinking about this claim, head H, that the coin will come up heads on its next toss. So that claim might have some objective probability, right, which will come down to facts about how the coin actually is, like how is it made, is it a fair coin or not. But then we've all got our own credences in H, right, which are kind of like our subjective probabilities or degrees of belief. And mostly today I'm only really interested in rational credences, so what your rational degrees of belief are given the evidence that you've got. Okay, so our subjective degrees of belief, our credences can come apart. Right? So it might be that you know nothing about the coin. For all you know, it's not biased, or if it is biased, you've got no reason to think it's biased one way or the other. So your credence in H right now is probably 0.5, but if I spent an hour after breakfast this morning tossing the coin, I might have my suspicions that it's biased and have a credence of 0.6 in H. And obviously my credence now could be different from my credence yesterday. So these subjective probabilities or credences change across time. Okay, so now what I'm talking about, so now I need to introduce the idea of conditional credences. So let's think about your credence that it will rain on Christmas Day in London in 2014. So what's your credence in that? So I'm really sympathetic to what Rosanna was saying yesterday, and maybe you don't have precise credences or degrees of belief in these sorts of claims. But let's put that to one side and put vagueness to one side for a moment. And see if we can say, just as an example, what your credence is in this claim. So let's say it's 7 out of 10. It rains a lot right now. It's probably going to rain on Christmas Day. And what's your credence that it will snow on Christmas Day? Well, it's going to be a lot lower. Let's say it's a fifth. And I've put it here in this part of the diagram because I'm trying to express the fact that you probably think that it raining and snowing on the same day. It's really unlikely. So the probability of rain and snow is really low, right? Because if it's cold enough to snow, it's probably not going to rain. So you've got more of a credence that it will just snow than that it will snow and rain as well. Okay, so now we have this sort of credence, a conditional credence. What's your credence that it will rain on Christmas Day under the conditional on the claim that it will snow on Christmas Day? So, what do you think it is? So intuitively it's a quarter, right? So we assume, we imagine a case where you know that it's going to snow, so you can discount all of this. And we just focus on this part of the diagram. You know it's going to snow, now what's your credence that it's going to rain? So it's just a quarter, because it's a quarter of this space. And so what we're doing here, what this means, your credence that it will rain conditional on the claim that it will snow, is just your credence in rain and snow divided by your credence in snow. Right, that's the sort of sum that we're doing here when we work out your conditional credence. Okay, so now updating. So on this sort of classic way of looking at things, there's only one reason to ever change your credences, and that's getting new evidence. And when you get new evidence, if you're rational, what you'll do is you'll conditionalize. So, for example, if this is your credence right now, suppose you were to find out that it's going to snow, you become absolutely certain of it, that the evidence you get is that it's going to snow. So we can imagine that an oracle tells you it's going to snow. So then what will your new credence function be? Well, it'll be this, right? So we've just taken away all the parts of this diagram that you now know don't hold and sort of blown this bit up. So if you've conditionalized on your evidence that it will snow, your new credence interval value will be a quarter. Right? So basically, whenever you gain evidence, your new credence in the claim is just your old credence in that claim conditionalized on your evidence, conditional on your evidence. So on this view, that's the only rational way to change your credences. Okay, so now I'm going to introduce the reflection principle, which causes all these puzzles and problems. So here's that claim again that the next coin toss will land heads. So say this is a coin that I'm about to toss. What's your credence that will land heads? We can imagine that you're thinking about this, and you also think about yourself later. So by the end of this talk, what will your credence be then in heads? I mean, suppose that you were to find out that at the end of the talk, you'll have a credence of 1 in heads. Well then, intuitively, you should have a credence of 1 in heads right now. If you were to find out you're going to have a higher credence later, you should have a higher credence right now. So that's just to say that your credence right now in heads, conditional on your credence later in heads being 1, should be 1. Okay, so more generally, here's the reflection principle. So for any claim P and any value B, we've got an agent at T0, and this is the same agent at the later time at T1. This gives the agent's credence at T0. This gives the agent's credence at T1. So your credence at T0 in P, conditional on your credence in P at T1 being V, should be V. So we can put this by saying that you should defer to your future self. You should treat your future self as an expert. If you find out something about the credences you will have in the future, you should have them right now. Okay, I just need to add something, it's a like qualification to this. This is just to say that it only works if your credence right now that you will have a credence of B and P later is greater than 0. This is just to avoid getting ourselves into a pickle, having to just divide over 0. Okay, so that's the reflection principle. And it seems kind of compelling, right? So as time passes, you get more evidence. So surely you get yourself into a better position to assess the truth of claims. So your future self is going to be a good guide to this, and you should defer to your future self. There's also what's called a Dutch book argument for the reflection principle. But I'm not going to go through that now, we're just going to focus on the intuitive appeal of the principle. Well, the principle isn't always appealing, so we can imagine these sorts of counter-examples. So this is Talbot's case. So here you are at T0, you're eating spaghetti right now, and your credence in S, that you have spaghetti for dinner at T0, is really high. Say it's 0.99, right? You can see it's happening right now. You think ahead to the future, like maybe in a year's time. And you think maybe by a year I'll have forgotten that I had spaghetti at T0. Maybe all I'll know is that I have spaghetti one day in 10. So maybe in a year's time my credence that in S will be a 10. So now, conditional on my credence at T1 in S being a 10, should my credence right now in S be a 10? Well, obviously not, right? So what's going on here is that you think that you might be in a better position right now to assess S than you will be in a year's time. So here you don't want to defer to your future self. So here's another sort of example. So this is Christensen's example. So here we've got claim F, which is that I can fly. And at T0 you're thinking maybe you'll take this hill LSQ, which will give you, which sometimes gives people a really high credence that they can fly. An irrationally high credence. So you think that maybe, in an hour's time, at T1, you'll have a really high credence that you can fly. Conditional on that being the case, should you have a really high credence that you can fly now? No, obviously not. So here again, what's going on is that you think maybe at the later time, you'll be in a worse position to assess F than you are now, because you might become irrational. Okay, so these are two cases where the reflection principle isn't appealing. So what some people have done to handle these cases is given a sort of qualified version of the reflection principle. So this is what I'm calling careful reflection. So the idea is that you should always defer to your future credence function when you're certain your future, only when you're certain that your future credence function will be just your current credence function conditionalized on some true evidence. So you're quite certain that by this future time, either you'll have exactly the same credence function, or you'll have got some new evidence and simply conditionalized on it. So surely in those cases, you'll just be in a better position in the future to assess a claim than you are now. So it seems here intuitively you should defer to your future self. All that's going to happen to that future self is that they're going to get some evidence and conditionalise on it in a rational way. And once we've reached this point, we might think, well, does it really matter whether it's the same agent in the future? Why do you only defer to your future self? Isn't what's doing the work here just the idea that this person's got all of your evidence and some more and then conditionalising it? Surely it doesn't matter whether it's you or someone else that's in that position. You should defer to them just the same. So then we end up with group reflection. So you should just defer to any credence function that you're certain is just your own current credence function conditionalised on some new true evidence. So you could end up deferring to two different agents. So you can imagine you're walking along a path with two friends, and let's just say that they've got all the same relevant evidence as you at this point. And you're all wondering whether you're close to the sea. And you get to a fork in the path and you sit down and rest, and one of your friends goes down one path and one goes down the other. And they might both be getting some more evidence about whether you're getting close to the sea. So they might be updating their credence functions, and let's assume you know that they'll do that rationally. So then, on this view, you should defer to both of them. And there's nothing obviously incoherent in that idea. I mean, of course it might be the case that one of them has got a high credence that you're getting close to the sea, and one of them has got a low credence. But you can still coherently defer to both of them, because all that means is that your credence that you're getting close to the sea, conditional on their credence having a particular value, is that value. So if you were to find out that this person had a high credence that you were getting to the sea, you would have a high credence too. And if you were to find out that this person had a low credence, you would have a low credence too. So it's not obviously incoherent to defer to two different people at the same time. It's just about your conditional credences. Okay, but nevertheless, the group reflection principle does lead us astray. So this is Luke Bowen's. He says, even if we modify group reflection along these lines are basically the lines I've said. So making sure that they have all the evidence we have and more, and they're rational. The restrictive principle can still lead us astray. Okay, so here's my example of a case where the principle will lead you astray. So I want you to imagine that there's a card game. So we've got 3 players in the game, and also a dealer, and you're just a spectator in the game. So the game works like this. The dealer is going to deal each player a card, just a single card face down. And this is T0, and then at T1, everyone will look at their own card secretly. And the setup's like this. So the dealer's going to secretly choose one of the 3 players to be the mug, and the mug gets dealt a black card. He's going to choose another player to be the lucky player, and the lucky player gets dealt a red card. And then the other player is just going to get a card picked at random from the pack. So it could be black or red, it's 50-50. Okay, so now let's think about your credence in 2 red. So what's your credence that 2 red cards have been dealt? So it's a half, right? So you know that the lucky player's got a red card, you know the mug hasn't got a red card, and the other player's 50-50. So your credence in 2 red is a half. Or I should say, all the players know the setup as well. They don't know which of them is the mug, but they know how it works. So the mug's going to get the black card and so on. Okay, so now you now, before the players have even turned over their cards, you can think about what their credences in 2 red are going to be when they turn over their cards. So you can actually work this out for 2 of the players. So we know the mug is going to turn over a black card, and his credence in 2 red is going to drop. It drops to a third. I won't bore you by doing the calculation, but I hope it's intuitive that it would drop. Right? So if you imagine you were playing this game, you didn't know whether you were the mug or not. You turn over your card and you see it's black. Your credence that 2 red cards have been dealt is going to drop, right? Because you might be the other player. We can also work out that the lucky player's credence in 2 red is going to go up. That it goes up to 2/3. And we don't yet know what credence the other player's going to have, because we don't know what colour card they're going to turn over. Could go up to 2/3, could go down to 1/3. We don't know yet. Okay, so now the problem we have is this. According to group reflection, you should always defer to any credence function that you're certain is just your own current credence function conditionalized on some true evidence. So it seems then by this rule you should defer to the mug at T1, right? So we can assume that at T0 you and the mug have got all the same relevant evidence. Then at T1 the mug turns over his card, gets some new evidence. All he does is conditionalise on that evidence, just as you would do if you had turned it over or got the same evidence as him. So it seems that you should defer the mug. But deferring to the mug means that you need to have a credence of a third in 2 red right now. And that's basically because you already know right now what credence the mug is going to have in 2 red at T1. So if you're deferring to the mug at T1, you need to have his credence function right now. Okay, so because you're deferring to him, your credence right now in 2 red, conditional on the mug's credence in 2 red being a third, should be a third. And your credence right now that the mug's credence in 2 red is a third is 1. So it works out that you have to have a credence of a third in 2 red right now. But of course the same goes for the lucky player, right? So the lucky player also, he had all your evidence, he turns over his card at T1, he gains some more evidence and conditionalises on it. So by group reflection you should defer to the lucky player at T1 as well. And that means that because you already know that the lucky player at T1 has a credence of 2/3, that means you should have a credence of 2/3 in 2 red. So group reflections making inconsistent demands on anything. You can't have a credence of a third and 2/3 in the same place. Okay, so what's gone wrong here? So I think that there's a very intuitive answer to this question. Of course you shouldn't defer to the mug at T1. And the fundamental reason why you shouldn't is because the mug doesn't know that he is the mug. So if you did know that he was the mug, you could defer to him, but then that would change his credence function. If he knew he was the mug, when he turned over the black card, his credence in 2 red wouldn't change. It's because he doesn't know that he's the mug that he has this credence of a third, and that's also why you shouldn't defer to him. So I spent a while being really confused about why you shouldn't defer to the mug, right? Because the mug really does have all of your evidence and more. But the mug doesn't know that he is the mug, but you don't know that either. I mean, you know that the mug is the mug, but the mug knows that too. That's just a tautology. The mug knows that the mug is the mug. So what the mug is lacking here is this sort of indexible piece of information that I am the mug. But it's not as though you have that information. You don't have that indexible information that he's lacking. So I think it really is the case here that the mug knows everything that you know and more. And he's conditionalised rationally, but nevertheless, you shouldn't defer to him. Okay, so here's why I think that is. So, is it always the case that when people get more evidence, they get smarter? Well, I think not, right? Because sometimes evidence can be misleading. Sometimes it can be unrepresentative. I think this about my son when I see him sitting and reading the Guinness Book of World Records. These are true facts that he's getting, but are they actually making him better at assessing the likelihood of claims? But only if he knows they're outliers. Right? So sometimes acquiring new facts can actually make you worse at assessing claims if the facts are misleading or unrepresentative. But that in general isn't a reason not to defer to people who've got more evidence than you. I mean, if they know everything that you know and more, if you know evidence is sometimes misleading, they know it too. So they should be able to correct for that. It shouldn't stop you deferring to them. The question is what happens when you've got a particular reason to think that somebody's got misleading or unrepresentative evidence. So if they know everything you know and more, then presumably if you know they've got unrepresentative evidence, they know that too. And so they can correct for it, and you should do that. But actually, for them to be able to correct for it, they need to know that they have got the misleading evidence. It needs to be that sort of indexical information. So for example, you can imagine an agent A who knows everything you know and then goes and acquires some more evidence. And you know that the evidence that A has acquired is unrepresentative. It's some unrepresentative data from the experiment. So should you defer to A? Well, you might think, well, if A knows everything I know and more, then that's fine, because he'll correct for the fact that the data he's acquired is unrepresentative. But in fact, that will only work if he knows that he is A. So if you know that A's evidence is unrepresentative, it won't be enough for him to just know that A's evidence is unrepresentative, unless he knows that he is A. Only then can he correct for having that unrepresentative evidence. Okay, so the change that I want to make to the group reflection principle is I just want to add this clause. So you only need to defer to a credence function when all those other conditions are met, and when the name of the credence function is self-recognised. So what I mean by that is that the person holding the credence function knows that that's the name of their own current credence function. So what this will mean in the case of the mug is that you don't defer to the mug because you don't defer to the credence of the mug at T1. Because that isn't self-recognised. The mug won't know that the mug's credence at T1 is his own credence at T1. But you do defer to, say, Bob's credence at T1, assuming that Bob knows his own name. Because that is self-recognised. And that seems intuitively right. Okay? So if you were to find out that Bob had turned over, Bob had a credence of bread in 2 red, then intuitively you would defer to it, in a way you wouldn't defer to the mug. But it might be, of course, that Bob is the mug. So the mug's credence at T1 is the very same credence function as Bob's credence at T1. Did I say that right? The mug's credence at T1 is the very same credence function as Bob's credence at T1. So they're just 2 different names for the same credence function. And I'm saying you defer to one, but not to the other. So what that means, of course, is that defers to, in my view, is an intentional relation. So whether you defer to a credence function depends on how it's designated. So you defer to the mugs but not to Bob's, even though those 2 things pick out the very same function. And that seems kind of intuitive to me, right? I mean, if you just think about the everyday meaning preference, like you can defer to someone's knowledge and not to them describe differently. So everyday examples might be where you ask a friend what they think about a holiday resort, and you believe what the friend says and you take on their credence function, you defer to them. Then you go on to TripAdvisor and you look at the very, very highest rating report. You probably wouldn't defer to that highest rating report, right? It's unrepresentative and you know it to be unrepresentative. But it might be that your friend wrote that highest rating report. So whether or not you defer to someone depends on how they're designated. But what this means, so here, this just shows how defers to is intentional. So here I'm saying that you don't defer to the mug, so your credence stays the same even under the condition that his is a third, but you do defer to Bob. So you change your credence function if you were to discover what his was. So you bring yours into line with Bob's, but not into line with the mug's. But what this will mean is that the content of credences have to be intentional. So this is just the way of cashing out what this conditional credence means. Right? We gave our definition of conditional credences in the beginning. And this is just cashing this out. So these two can only come apart if either this isn't equal to this, or this isn't equal to this. But that seems fine to me. I mean, I think, of course, your credence say that the mug has a credence of a third in 2 red. It's going to be different from your credence that Bob has a credence of a third in 2 red. But you know that the mug, after he's turned over his card, you know he's going to have a credence of a third in 2 red. Because you know that the mug is being done to black card. But you don't know what Bob's credence in 2 red is going to be, even though Bob and the mug are the same person. So this view commits me to the claim that the contents of credences are intentional. But I sort of think that that's fine anyway. I mean, we're used to the idea that the contents of belief are intentional. Credences are just, like degrees of belief. Surely they should be intentional too. So your credence that an object has a property can depend on how that object is designated, right? So it seems like an uncontroversial thing to say to me. Probability theorists and statisticians are people but they don't like this part at all, the idea that the contents of credences can be intentional. And I'm still in the process of working out why. I think it's because lots of their moves and their axioms fail if we make this claim. But what I want to show next is that I think that they're already committed to the claim that credences have intentional contexts. They have their own solution to some of these puzzles of reflection. And I think that their own solutions implicitly rely on the idea that the contents of credences are intentional and that deference is intentional. Okay, so to show this, we're just going to go back to the first reflection principle I talked about, the one where there's just one person, right? So you're thinking about yourself in the future. So this is just the claim that you should defer to yourself when in the future, when you're certain that your future credence function is just your current credence function conditionalized on some true evidence. So there's lots of puzzles about this reflection principle in the literature. So Sleeping Beauty paradox, the Cable Guy paradox, and Aunt Xenius's prisoner cases are all examples of this. But I think all the puzzles have the same source. And I've just got a really simple example to illustrate how I think these puzzles work. So this is what I'm calling the coin toss. So let's say I've got a coin and it's T1 right now. In a minute I'm going to toss it, and if it comes up, I think that should be tails. Yeah, imagine this says tails. So if and only if it lands tails, then I'll toss it one more time. If it lands heads, then I won't toss it again. So it'll just be one toss if it lands heads. So now I'm defining the future time T1 as the time immediately before the final coin toss. Okay, so there's 2 times when it could be. could be in a minute, just before the first coin toss, or if the first coin stands tails, it would be the time before the second coin toss. Okay, so what would you do if you were to find out that at T1, your credence that the first toss landed heads was a half? Would you defer to your future self at T1? So, if you found out that at T1 your credence that the first toss landed heads was a half, you would immediately know, right, that T1 must come before the first coin toss. Otherwise it would have been 0 or 1. So if you know this, then you know that T1 is before the first coin toss. We've defined T1 as being immediately before the last coin toss. So that would tell you that there's only going to be one coin toss, which is what happens in heads is true. So if you were to find out that at T1 your credence that the first coin toss landed heads was a half, then your credence in the claim that the first toss landed heads shouldn't be a half, right? You shouldn't defer to yourself at T1. It should be 1. So here's a case where you shouldn't defer to yourself at T1. But we can say that you're completely sure at T0 now that you won't have lost any evidence by the time you get to T1. You might have gained some evidence, and all you're going to do is conditionalise it. So this is the sort of case that the reflection principle seems to say you should defer to your future self. But clearly you shouldn't in this sort of case. So what's gone wrong in this case? Well, there is three statisticians, Skirmish, Seidenfeld and Cadent, who set out to solve these sorts of problems. And they use this term that's used in statistics called stopping times. So they say that the reflection principle should only be applied when the future time is what they call stopping time. And they define stopping times. I won't read it out. Maybe I'll define it intuitively for you. Okay, so here's the definition, or well, here's an example to illustrate stopping times. Roughly the idea is that a time counts as a stopping time if you'll know when you get to it that you've got to it, and you'll know at other times whether or not you've got there. So here's an example. So let's suppose I wanted to build up some data about how many women ask questions, how many men ask questions, do some analysis on that. So after my talk, I could be, keeping tally. Like every time someone asks a question, I'm filling it in. And at some point, I'm going to stop collecting data and do some research on it. Okay. So when could I decide to stop collecting data? So here's one thing I could do. I could decide to stop when the proportion of questions asked by women divided by the number of questions asked by men is at its lowest point. That's the sort of thing you might try to do if you wanted to sort of massage the data, right? To pick it at a particular point. But that's not the stopping time, right? So, suppose that 5 minutes in, the proportion was quite low. I might think, well, is this it? Is this its lowest point? Is it going to get lower? I've got no way of knowing, right? So this wouldn't count as a stopping time. This, on the other hand, does count. So say if I thought, to stop at 4 p.m., that is a stopping time, right? I can just look at the clock and know whether or not it's 4 p.m. So their solution to the reflection, their response to these puzzles about the reflection principle is to say, you should only apply the reflection principle when the future time is a stopping time. So you can see how it worked in the coin toss case, right? I said that T1 was the time immediately before the last coin toss, but you might not know when you get to T1 that you've got there, right? So think of the time just before I toss the coin for the first time. You don't know whether that's T1 or not, which we don't know whether there's just going to be one pointers or two. Right, so T1 isn't the stopping time, so that's why you don't have to declare to yourself at T1. Okay, so the problem solved by the statisticians. But I think that what the point I want to press here is that I think whether or not time is a stopping time depends on how it's designated. It's not times that are stopping times, it's times under a description. So you can see that here, right? So we said this wasn't a stopping time and this was a stopping time. But of course it might be that the proportion of questions asked by women over the proportion of questions asked by men, the number of questions asked by women over the number asked by men, is at its lowest point at 4 p.m. So these could just be two ways of designating the very same time. And they've told us that one is a stopping time and one isn't. And that tells me that if a stopping time, this is an intentional context. So it matters how the time is designated.